And here's question number 15 from the Stoichiometry review quiz. An acid-base neutralization reaction was carried out between 12 grams of hydrochloric acid and 24 grams of calcium hydroxide to form 5.9 grams of dihydrogen monoxide, that's water, and 32 grams of calcium chloride. Determine the limiting reagent. Remember that the limiting reagent is the stuff that runs out first, the reactant that we run out of first. So when I'm looking at forming stuff, I don't even care how much product we're making. Limiting reagent is really just going to be one of the reactants. First step, always, is to have a balanced equation. So you have an acid-base neutralization reaction. Hydrochloric acid is HCl, and calcium hydroxide. Calcium is Ca, hydroxide, remember, is one of our polyatomic ions. It's OH, the charge of -1. Calcium has a charge of +2, which means we actually need 2 of these to balance out the -1 and the +2. We're going to form that dihydrogen monoxide, water, and calcium chloride. Remember that chloride has a charge of -1. Calcium's a +2, so again, I need 2 of these guys. To balance the equation, I have 2 chlorines here. I only have 1 here, so I'm going to plop 2 in front of this guy. I now have 2 H's and 2 OH's. Each one of those H's and OH, that H and that OH, are going to form water. So that's our H2O. So I have 2 and 2, means we're actually going to make 2 waters. I'm looking for the limiting reagent. We have 3 different methods that we like to pick from. We can flip one of our reactants into the other reactant and then think about how much we have and how much we need. Do we need more than we have? Do we have more than we need? Or we can convert the masses of both reactants into moles, divide by the coefficient in the balanced equation, and pick the smallest one. Or we can turn them both into product and then pick the one that makes the lesser amount of product. I'm going to go with method number 2, which I think is the one we pick most often. It's the fastest. So again, we're going to turn our masses into moles and then divide by the coefficient in the balanced equation. So I've got 12 grams of HCl. I'm going to turn that into moles by dividing by the molar mass. On the periodic table, hydrogen is 1.008 and chlorine is 35.453. When I add those up together, we get 36.461 grams. 12 times 1 divided by 36.461 is 0.329, lots of decimal places. We're going to divide by the coefficient in the balanced equation. That's going to give us like a 0.1764, maybe 0.16 something, HCl. Now let's do the same thing for our calcium hydroxide. We've got 24 grams of calcium hydroxide. And divide by the molar mass once again. So calcium is 40.078. I have 2 oxygens, so 2 times 15.999. And we have 2 hydrogens, 2 times 1.008. Add those all up together, 40.078, 2 times 15.999, 2 times 1.008, gives us a grand molar mass of 74.092. 74.092 grams per mole. 24 times 1 divided by 74.092 gives us 0.3239, lots of decimal places. Divide by our invisible 1, leaves that at a 0.32, lots of decimal places. So now we compare. We have a 0.16, almost a 0.17, 0.32. 0.16 is less than 0.32, and so hydrochloric acid is our limiting reagent. Make sure that you divide by the coefficient in the balanced equation. If we had not done this, if we had instead just compared mole numbers, then this guy would actually have been just a smidgen smaller. It's that dividing by 2, because of the 2 in the balanced equation, that actually shows hydrochloric acid as the limiting reagent.